Hello, everybody. Just looking at the time, I'm just a little bit early, so I'll wait until 11 before I get started. But either way, everything's filmed. But I hope everyone is making the best of getting locked in at home and not being able to go anywhere. From what I've heard now, the government and UNSW are stepping up even further on public gatherings and things. And I noticed that in the recent government announcement that said no gatherings of more than 100 people in any indoor situations. This time, I don't think universities were exempted from that, so I think that's going to mean that the majority of classes and things are going to end up online in the next couple of days. I think with something like UNSW, it's just a matter of trying to rearrange everything. So just trying to find a way to actually continue teaching while taking it online. So hopefully everyone is enjoying it. I'm sure there's a significant percentage of you who still haven't gotten out of bed yet. You just managed to grab your laptop and pull it closer to yourselves to to listen to this. And so for some people, I'm thinking this might be this might actually be quite a convenient thing for you. I've been getting reports back from the tutors. Please be patient with the tutors, because at no point have we had time to train them properly in online education. So a lot of them have been trying to teach the same they would face to face, and it's very hard for them if they don't get much feedback from you. And they're used to being able to look at your face and just get enough feedback there to see whether things are getting through or not. And so without that, it's a little bit difficult, I think, for a lot of them to teach in the same way that they would have taught. But we're hoping with a little bit of time they will be able to adjust to this. And either way, the content is still the same content that we've written and the same content that we trust. But it's just difficult when you can't just look at your tutor and then they know whether you get something or not. I don't know if anyone heard that. That's my the guest lecturer for today. I didn't realize she was still in the room. She was hiding under my desk, so she's hanging out here for a little bit, but hopefully she won't distract people too much. She's like, what are you doing? Okay, so let's launch into so some people are talking about travel time and stuff. So yes, this does save travel time. But also, people have noticed the cat. We're working on the assignment as well. No, I can't just keep bringing back the cat. We do have work to do today. I'm not just going to show you cat videos the whole day. Although I should ask everyone to like, follow, and subscribe and all that kind of stuff. You don't actually have to do that at all. The weirdest thing about having a lot of you subscribing to the channel is now I've appeared on YouTube, and so I've got random bots and things. You've noticed these random people who no one knows commenting on hello. Okay, get back there. You may have noticed random people commenting on the channel, so I'm just kind of like going to keep that at least mostly just to everyone in the subject. Okay, so now that we've had a good look at my cat there, she's a different. I used to have two cats. One of them passed away sadly, but I think I can't remember when I last put a photo on the forums of my cat. It must have been this cat actually, because the other one passed away before this term started. Okay, let's get going into the lecture itself. I mean, we're still not at 11:05, but I'm not keeping super strict to the starting 5 minutes after the hour thing now, so I will probably be starting the lectures a little earlier than that. I mean, It depends. Val North's asking what my cat's name. The cat's name is Chicken, which we always think is a funny name for a cat because you know, like when they sit down, they look kind of like a roast chicken. Anyway, yeah. So, okay, let's get on to actual content because it's now 4 past. So I think it's okay now for me to start talking about content because it's enough time for everyone to get here. I mean, a lot of our normal restrictions, which were based on you walking between lecture theatres and things like that, sort of don't come into effect anymore. So I think it's probably okay for us to start talking about content now. Oh, it's not intended as a macabre name at all. It's really meant to be like just a cute thing, like she's a chicken, like cats run away from stuff and things like that. Anyway, let's get into the actual lecture. I mean, she is here in the room with me, so she's probably going to make other appearances every time she gets bored, and within 2 hours she's going to get bored again. Okay, so what were we looking at yesterday? So yesterday, I mean, we actually spent a fair bit of time yesterday on pointers and functions as well, but that was kind of a flow-on from last week, where we were talking about how to use pointers, how to put pointers into functions, and how to build a super, like if you're talking about style marks, what I did yesterday was sort of a demo of how to score really highly in style marks by pushing a lot of unnecessary to read code into functions and being able to have a main function that's just really short and mostly words, just saying do this, then do this, then do this, then do this. I'm not saying that you have to do that for Minesweeper to get full marks or anything like that, but if you do, if you really do want to push for what I would call professional level code, that's the direction you want to aim in. At no point am I expecting the first assignment in your computing degree to look like professional code. Right. So this level of the expectations I have is that people have never seen C before 4 weeks ago, and then by the time the assignment's due, you'll have a total of 6 weeks worth of training in C. So I'm not expecting you to even be writing code that someone would pay for at this point in time. I'm happy if what you're doing is creating code that you're happy that you learned something from. You know, that's the level that I want people to be at. It's like, oh, okay, I did something new in this assignment, and this is something that I hadn't thought of before. So I managed to piece together some ideas that I'd had in labs and stuff like that, and when that all came together, I got a larger piece of code that started working. That's what I'm aiming at. But for those of you who are supremely confident in this and are happy with everything you've learned so far, I'm also happy for you to push further, and that's why we have stuff like the Hall of Fame challenges if people really want to go for it. But I should remind everyone that if you put a whole lot of hard work and effort into this and it's really difficult and you get as far as like through stage 1 and maybe a little bit of stage 2, that's actually the competence level that we're looking at for this assignment. Like, this is not like a high school assignment. Like, when we work on things in high school, you're expected to complete all the tasks that are set out. The staging system in the assignment, and the reason why every stage has this little thing in it that say you don't actually need to complete this to pass the assignment, that's actually a genuine piece of advice there, is that if you're still learning, you may get more out of doing the tutorials and labs than you get out of the assignment, because the assignment might just be sort of smashing your head against a brick wall in a sense. And so do as much as you feel comfortable doing, and then if you really do want to go further, you can talk to your tutor or help sessions about it. Help sessions are now running fully online. You should be reasonably familiar with them because, as far as I know, they are running on exactly the same system that are running in your tutorials and labs. So that's Blackboard Collaborate. Sorry, I should check chat because there's been a lot of talking in the chat. Although I see at least one of the tutors in chat, which is very nice. So Michael, say hi in chat. Michael Gribben is one of the tutors, so he might be able to actually answer your questions in chat while I'm talking. There you go. Michael's there. Oh, Alvin's there as well, so we do actually have a couple of tutors in chat, which is really nice. I should make you guys moderators at some point. I'll do that later, though. I'm not going to do that right now. William saying, yes, stage 4 is like smashing my head against a steel wall. So my advice for anyone who is smashing their head against a part of the assignment like that is please try to go back to what I've been trying to teach you about problem solving and stuff, breaking things down into smaller parts, trying to answer only part of the question at the time and then building it up. You may find that breaking it into smaller parts puts you in a situation where some of the earlier stages are actually quite useful to continue using. But, you know, I'm not going to I'm not going to tell anyone how to do the assignment because that's going to take the experience away from you. But if you need personal help with things, so Milkshake, if you're saying I'm stuck on stage 2 and there's things that you want to know about, like, feel free to pop into a help session. I would say pop into the help session earlier rather than later. Even if you don't have specific problems, you can just talk to someone about where you're up to and things like that. Finley's asking about, is it better to have fewer large functions or piece those functions out for more smaller functions? So it's a little bit of a yes and no question there. The reason I separate things into different functions is if they have a different purpose or functionality. So it's often me saying, like, remember the way I separated out the last example. So we had the thing that reads stuff in, the thing that prints stuff out. Obviously we don't want them in the same function because they do completely different things and they're going to get called at different times. But then when we had the jumble function was going to call swap many times, but swap has slightly different functionality from the jumbling itself, and that's why I separated those. So it's not necessarily a question of the size of the functions that make you need to swap them. I've got swap on the mind. It's not the size of the function that makes you need to separate it into a function. It's whether it does something different. So the focus is usually on whether it does something completely different. Yep. Oh, and Michael's answering some questions there. I'm going to let Michael answer the questions. Okay. So yesterday we were also covering debugging. VLab was not working for me very well yesterday. I don't know exactly the reason for that because it's always worked in other live streams I've done, and it worked later on in the day. Also, happy to announce that it is working fine now. So I'm going to use it now. I am also set up to go via SSH, which is one of our other ways of doing things if I have to, but hopefully we'll be fine with VLab. Right. No, that's alright. Thank you, Michael. Michael's sorting out all of those questions there, so I don't have to go back and forth to the chat that much. Okay. Something I want to continue on from yesterday, because we didn't look at any code examples of this, but we are definitely going to look at code examples today, is characters. So we introduced a new variable type that can store a letter. To remind you, the characters are able to store letters and symbols and things, but they are actually encoding them all in the same way as an integer. So there are ways to store a character in an integer variable. There's also ways to treat a character as if it's a number, but it's actually not that often that we will need to do raw calculations on the characters. But sometimes you do, because there are actually ways to shift characters between upper and lower case using the numbers. But as I showed you yesterday, there's also a set of functions in the ctype.h library that can do that for you. So there's often ways to do it without needing to actually do these raw calculations. Today we're going to look at strings. So strings is looking at, I guess the easiest way to think of them is words, but they're not just words, they could be whole sentences and things. They're basically arrays of characters. And we're going to look at how we can put characters into an array and how we can work with the characters that are in the array. So it's a little bit different from the arrays that we've been using so far. There's a little bit of subtlety to them because collections of letters are very rarely of a uniform length. You know, we make an array that has 10 items in it, we put 10 numbers in it, we go, okay, this thing's always 10. Whereas if I have 10 letters for a word, I could think of thousands of different words that are not exactly 10 letters, right? So we will have a special mechanism that allows us to use part of the array but not all of the array. And, I've been slowly building up to this. I've been dropping hints that we could use part of the array but not all of the array. Strings have a specific way of doing that. I'm going to talk about that later. We're going to do a code demo using characters and strings. So I've got strings and structs here, but I'm going to do structs at the end because I'm going to do a code demo using strings. And that code demo, for me, that marks the halfway point of 1511. Because we're in lecture 10 now out of 18, so we're actually, numerically, we're kind of past the halfway point, but this is the point where I consider the subject matter to be about halfway through, and structs comes after that, so we're going to talk about structs after we do our kind of halfway demo. I'm just going to check if anything's happening in chat. I'm going to assume that Michael is helping you with those questions there, and Alvin might be there as well answering some questions. We'll see how we go. Structs we're going to look at later on in the lecture today. Structs are interesting because they are, struct is short for structure, but the keyword in C is just struct. They're really interesting because they're containers that don't just hold the same variable type. So arrays, for example, all held integers, and you couldn't put any other variable types in an array. A struct is a custom variable that we can build that is made up of other variable types, and it can be any kinds of other variable types. So we're going to go through a demo. I don't know if I'll write code, but I'll at least talk through a demo of them this afternoon. Oh, I guess it will be afternoon because it'll be after midday by the time we get to that. Okay, strings. So yesterday we saw characters. We saw the char variable type, and we know that those are variables that have ASCII codes, which are, you don't really need to know what the ASCII codes are, but all you need to remember is that they're a number that represents a key. It's nearly like a key on the keyboard, because pretty much every key on the keyboard has an ASCII code. But most of the time we're going to be using these as characters, as letters. So now we can string together multiple letters into a word, which is what we call strings. Strings aren't necessarily one word, though I could put multiple words in a string. So a string is an array of characters. As I said before, we don't always fill up an array entirely with characters. So if I have something where it's like type in your name, if I just look at all of the names in the live chat at the moment, there's heaps of different lengths of names. Like I'd say the average length of name there is maybe about 15 characters. But some people have their first and last name there. Some people have their YouTube tag instead. And so some people have very, very long names or very, very short names. But if I wanted to have a string that could hold anyone's names, it would have to be larger than any of those names. So what we have now is a new character we're using, which is actually marking whether or not where we've used the string up to. So we used it up to a certain point, and the rest of it is empty and we're not using it. And so that's where we have this particular character. It's a /0, and it's called the null terminator. So the null terminator is something we put in after the last letter that we were using in an array. And then what it does is it tells us, hey, if you're looping through this array of characters, if you're looping through this string, you have now reached the end of what we considered to be functional for the string. Everything after this is memory that we have allocated to us but we did not use. So please don't read it, because you're going to get gibberish letters, or you're going to get all zeros or other things. Like we can't be sure, because if we have never initialized it, then we don't know exactly what our compilers are going to do. All compilers, well, not all, but most compilers are actually going to treat it differently, so it's very hard to tell. Just checking, are we getting a lot of background noise? Because I can hear a lot of traffic noise coming in my window. I'm not sure if you're getting that background noise or not. Let's just see if people if you can hear me fine. I think this is going to be the problem from now on with the Wednesday one, is that there might actually be some cars driving around. Although obviously noticing there's a lot less cars than there have been in previous times. Some people saying it's okay, but other people saying they can definitely hear it. A little bit, but not too bad. A lot of noise. Okay. Lots of background noise. Alright, so it depends on whether you can hear my voice or not. Let me just shut the window. I'll be back. Alright, I'm back. That's a little quieter, and it's quieter because there's no cars outside right now. Yeah, we'll see how we go. Right, we'll see what's happening there. Okay, so some of the structure for how we use strings and how they appear in code. Since a string is an array of characters, we would declare it in the same way that we would declare an array of characters. But there are some interesting things we can do. So we could have done this anytime we wanted to declare an array. We could have actually declared an array and put the curly brackets here, and then the size would have been chosen for us by the number of characters. This happens more with strings than it happens with normal arrays, because usually with arrays we're going to be really careful. We're going to like hash define the size of it, or we're going to pick the size in advance before we do anything with it, and then it's going to be at a fixed size. You can do this with arrays as well. This is actually not the safest way to do it, but often this happens with strings where we don't know exactly the length, but the length is going to be fixed by the number of elements we put in. So if we declare a character array and we say we want to put these characters in, this would say I'm going to use exactly this much memory to store these characters, and I'm going to store exactly these characters in there. However, we also have this nice shorthand here where we could say I'm just going to use these double quotes and say this is the word, and then it'll automatically put the null terminator in there. And then this is what it's going to look like in memory. Each of these sections is going to be 8 bits, and each of these is going to store the integer code for each of these characters, including the null terminator. So this is a character. It takes up 8 bits, and it just stores the fact that the string is ending here, and the one just before it was the final readable character in that string. This double quotes one is kind of interesting because this is like a whole lot of other things in C where I've just sort of shown it to you and you've been using it for ages, like right from the very first program. But I'd never actually defined it as an array of characters before. So if you put double quotes around any text, and you've been doing this in all your printfs and your scanfs as well, this defines it as it will end up acting like a null terminated string of characters. So once you were to store this thing in memory, it would store in memory like this. When you use it just as it is like that, it's just a value in the same way that we could type a number into our code and it's just a value, but it's not stored in memory yet. But once you save this, then it can be put in there like that. I'm going to talk a little bit more about this because we do need to remember that these are arrays, and we need to remember that we can't usually put a whole bunch of separate integers into an array at the same time without looping through it. This initialization allows us to do that, but when we're working with them later, we can't necessarily just go, this string equals this whole bunch of characters. We would have to loop through and grab them one at a time, but we'll get into that. Okay, reading and writing strings. We have some extra functions that we can use. So with our standard input-output library, we were looking at a lot of the functions that we got. So scanf and printf are things that we've been using for a while. Yesterday I showed you some of the other things in the standard input-output library, like getchar and putchar. We're gonna use them today, so we'll see how they work. There's also the ability to read an entire array of characters in at any particular time, and that's this thing called fgets. Fgets will actually take one line of input. So I could type text for a while and then press enter, and then that entire line would go into a single call of fgets. So we're getting now different capabilities to pull data in from our user. So the first thing we had was scanf. Scanf tries to look at what the user has typed in and say, does this match the patterns that I'm thinking of? If it matches the patterns I'm thinking of, it will then pull the it'll pull whatever has been typed in, and it will say, how do you match the variable type that I'm looking at? If you do match the variable type, the pattern, the percent pattern, then I will convert you to the type of encoding that is, and then I will write that into my memory. Getchar that we looked at yesterday just simply takes one letter, so it's nearly like one key press. Not all of those are key presses, but it takes like one key press and says, okay, I'm only going to take that one key press, and I'm going to put that into whatever memory that I've been told to put it into. fgets does a similar thing where it gets memory, but it gets a big chunk of memory. So it's expecting a character array here, and it says, okay, what's the maximum length that I'm going to get characters of? And then the stream. So for the moment, the only stream we're going to be using is the standard in. So standard in is the stuff that gets typed into the terminal, or if we're running your auto tests, it's the stuff that we pipe in to your program. So we pipe automatic input into your program that simulates the same thing as someone typing in. There are other streams like file streams, network streams, and things like that. We're not going to be covering any of those in this subject. We're going to sort of just teach you how to handle the streams, and then later on in other subjects you'll learn how to open other streams and work with them. So, standard in, user typing in the terminal. fgets allows us to read an entire line. I'll just check if there's any questions. Oh, looks like Michael's answering. I'm going to assume that you're answering all the questions, Michael. Thank you very much for hanging out in the lecture and answering questions. So this is one nice thing about actually doing this in a live chat, is we actually have some experts in text, and so a lot of people hopefully getting some stuff there. And if you re-watch this video, you could watch the first time just listening to me, and the second time you could go through and see what's happening in a live chat, because the live chat will replay in the recording. Just making sure my face isn't blocking any of the slides, but probably okay. Yeah. So here is one of the uses we could have of fgets, and I snuck in something new here. Depending on what the output of a function is, we can actually put a function call as the question bit in something like a while loop. So this fgets call in here is going to return the status of whether it has succeeded or not. So if I remember correctly, fgets in its return will return a pointer to the array that it's written into, I think. We can look this up if we need to. But sometimes if it doesn't read anything in, so if there's nothing in the line, it will return null. So our while loop now, every time we run it, it grabs a line of text. So it grabs a line of text from the terminal, and then here we're going to use fputs, which is the opposite of fgets, that's going to write that same line. So basically, this little bit of program here reads a line and then writes a line. It just reads and then writes the same line. So the way that it works is every time the while loop runs, it tries to get a line of text. If fgets could not get a line of text, so if we've got an end of file, then it will return null, and when it returns null, this while loop won't run, so we won't try to write the text back out. So these two here, standard in, standard out, those are our streams. So a stream is a kind of a flow of information in a sense, and you can consider the standard in to be the flow of information coming from the user as they type things in the keyboard, and the standard out to be the flow of information as we display characters to the screen for the user to read. So standard input, standard output, that's the way we think about them. The string library also has a bunch of helpful functions that we can use for things. So when you look at the specification of string.h, so string.h is something we can hash include in the same way standard input output, ctype, math.h, stdlib, standard library, all of those are things that will always be available in any C program. We can include them if we think we're going to use them. When a function in the string library says char star s, actually, 1 second. I'm going to put that in the correct. It's finicky, but we like to put the star next to the variable because then it reminds us that this variable is a pointer. Sometimes if you put the star here, there's a lot of subtleties to that. I won't bother going into that right now, but I like to put the star on the variable itself. Oops, I'm going to change that up here as well. So, just make sure that we have... No, that's alright. So, a lot of the functions in the string library are going to have this char star s, which is a pointer to a character. And if you recall, the way that arrays and pointers were similar was the fact that we could have an array. If we don't put the square brackets on it, we pass an array around as a variable. That array would have as its value the address of the first element of the array. So the array as a variable can be used as a memory address, which means that we could give that as a pointer or as the memory or as the array itself, and it would be the same. It would appear the same. So it would be the memory address of the start of the array. So this character pointer s is like saying, I'm going to give you a memory address where a string starts. So we can nearly think of, when we're looking at characters like this could be a pointer to a single character, but usually the convention of this character pointer is it's the start of a string. So all of these will take char stars. We call them char stars sometimes. Character star s, and string copy, string concatenation, and other things like that. These are all functions that exist in the string library that can just do some easier things for you. So strcpy, I spelled that wrong here actually. Unfortunately, I tried to type it in like a human would, and I put an O in the copy, but a lot of this stuff is abbreviated. So when we're doing work with strings, it's really annoying to try to copy one string into another because you actually got to write a while loop that grabs the characters one at a time and shifts them from one array to another. As we've seen, I think we've definitely done some lab exercises like this where you had to copy one array into another, or you had to create a new array out of pieces of another, and there's no way to do it other than looping through the indexes and just like copying the elements one at a time. When we're working with strings, that gets a bit annoying, so we have functions that just go, alright, just take one array and make a duplicate of it in this other array. So that's nice. And we have other things where we can attach strings to each other. We have something that compares two strings and says whether they're the same as each other or not. It also even says how they're different. So I think it will give you information about whether they're alphabetically, which one's first in the alphabet as well. We can find characters inside strings as well. So there's a whole lot of stuff here that if you want to, you can look in the string library and see if there are some useful things in that. We will be going into this kind of stuff in our tutorials and labs as well. I should remind everyone, I'm definitely going to make a notice about this and everything, is that we do have our sort of mid-session break coming up. They don't call it a mid-session break because I'm pretty sure at the moment it's still optional. Term 1, it's still optional, so not all classes will be doing it. But week 6, which is next week, is the flexibility week, and the flexibility week was intended for you to be flexible about whether you needed to spend time on your face-to-face teaching or not. I mean, obviously none of the teaching's face-to-face anymore, it's all remote, but still, all the lectures that and other content that we deliver in week 6 will not be accessible. So it'll be interesting things that you might want to work on or not. The beauty of it at this stage is that the assignment is due at the end of that week, which means you actually have a week where you don't have to worry about lectures, you don't have to worry about learning new content, you don't have to worry about completing a lab or anything. The weekly test from last week is still due midway through the week, but that's kind of last week's that's like well, this week's content, so it'll be the content that we release tomorrow. But otherwise you will have less responsibilities to deal with that week. We're still running some stuff. So I actually have a guest lecturer coming in who is going to... I think the way we're going to do it is probably not going to live stream, because live streams are all coming from my laptop here at home, so I'm not going to make him come over to my house to do things. But he will probably record some videos that I'll make available. I'm going to do some live streams as well. And I haven't decided yet, but I might do a lab that is entirely optional exercises. So I might do a lab that has no marked content, but just has some interesting random stuff that you might want to look at doing. And I'll make it stuff that uses all of the content that we've had for the first half of the course. Yeah, just looking at what's happening in the chat. Looks okay. Looks like Michael's answering everything. Okay. So, I don't know who gets the title or not, but well, we're halfway there. So we are halfway through the course now in terms of content. So the first half of the course was me showing you how to use variables, and then me showing you how to use loops to do repeated things, and then I linked up arrays to those loops, which works really well, because if I give you a chunk of memory that has multiple parts in it, it's really nice to be able to loop through that memory. Living on a pear, thank you very much. Okay, I should, just in case people are not necessarily, don't necessarily know this, if you've ever been to karaoke in a pub in Australia, chances are you've heard this song whether you like it or not. The song's called Living on a Prayer by Bon Jovi. It's one of those songs with a chorus that is just really, really easy to remember, because it starts off like this. It's like, whoa, we're halfway there, whoa, living on a prayer. Anyway, that's enough of me singing. Usually this is more fun, because usually I'm in a lecture theatre and someone will laugh at this, or someone will go, oh my god, my lecturer is singing, what the hell's happening? So I like that song because it marks the halfway point of things. And so at this point it would be nice to put a program together that uses a lot of what we've seen in COMP1511 so far, and especially strings and characters, because they actually tie in a lot of the other stuff that we've learnt. And then what we can do is we can sort of capstone this half of the course and go, okay, this is everything we needed to know at this point. Your assignment is similar, but this is actually more, because your assignment doesn't have some of the later stuff we've done in terms of characters and strings and maybe pointers and things. I mean, pointers I could nearly consider to be something that I needed to introduce to you. I needed to get you to start thinking about it, but it's actually more second half of the course than first half of the course. Just reading the response. Alvin's suggesting that I could play that during the break. But the funny thing would be is if I get copyright struck, and then we end up with a lecture that you can't view. So I'm not going to play any music during the break. Or maybe my singing was so perfect that we're going to get a copyright strike because it was so perfect. Hillary's asking, when are our next weekly tests? Our next weekly test is tomorrow. So there was the one last week. I apologize that we accidentally made the permissions for the one last week to be student rather than public. So if you weren't logged in, you wouldn't have been able to see it on WebCMS, but it actually was available the whole time, but people had to log in. If you have any trouble in terms of trying to get that finished by 5 p.m. tomorrow, because we didn't make it public until this half of the week, let your tutor know and we can probably push the date back for a couple of people if you need to. Like, we can always at least give you like sort of 24 hours on this one, just to give you a chance if you're a little bit late getting to it, and then you can do it on Thursday or on Friday or something like that. So the next one, yes, Alex, we are not monetized. That would be super awkward if my lecture material's monetized and you're forced to watch ads during your lectures. I'm pretty sure it is, right? I'm pretty sure no one's having to watch ads to watch my videos. If they do start showing ads, let me know. It means I haven't set something up properly, because this is meant to be like freely accessible, because I'm definitely not getting money out of the YouTube channel. The YouTube channel's just out of convenience. Oh, Tom's here as well. Here's our subject admin here. Okay, so what was I going to say? Was there another question? Oh, about weekly tests. So there is one weekly test that's due this Thursday. If the sort of pseudo late release caused you problems, buzz your tutor. They can probably give you an extra day. The next one will be released tomorrow, but there won't be one released in week 6, so there'll be a gap there. So one of the nice things about this is when your assignment 1 is due, exactly at the point the assignment 1 is due, you will have no other responsibilities for COMP1511 at all. So you won't have a lab to work on, and you won't have a weekly test to work on. So at that point, you're completely free to just work on the assignment. Should also say that help sessions are running, and they're running remotely. Oh my god, I'm just looking at the the chat. So, irony of this, I'm currently using a Logitech webcam. I have gotten shout-outs from Games Workshop and Warhammer before, but I've never officially been sponsored by them. Anyway, and no, we're definitely not going to have ads from those horrible games that like to spam everyone with all those ads. Okay, so halfway point, let's build a program that has a lot of what we've seen so far, but also has a focus on strings and characters, because I do want to look at strings and characters. So this is a word game. The first thing it's going to do is read in a string from the user, and it's going to store that string somewhere, and then it's going to read another string from the user, and it's going to tell us how many letters from the second string appeared in the first string. So in a way, it's asking how well do these two strings match each other. So if the number that we get back out of this happens to be the same number as the length of the string, then we know that those strings are, what's the word, anagrams of each other, where all the letters in one are in the other, but they're not even exactly anagrams, because we're not going to count that they have exactly the same number of things, but we're just going to count if all of the letters in one are in the other. So we're going to be using a whole lot of what we learned so far. If, while, arrays of characters, functions, and pointers. In fact, I don't think I've taught you anything else. So I haven't done this since last term. So I didn't know that we were definitely using pointers in this particular example. But I think we're going to be, because anytime we're passing an array into a function, that's us passing the memory address of the array into the function and stuff. So we are kind of using everything here. Alright. Every problem, every large question like this starts off with us breaking down the problem into parts. So it's nearly like thinking about a big problem in code. The first thing I think about is what in that am I going to ignore? So at the beginning of any problem, I'm going to say some of this stuff is later and some of this stuff is now. So the first thing I'm going to do is say, before we did anything, we were going to need to read in a line of characters. And then we were going to need to read in a second line of characters, and with that second line of characters, we were going to check if those characters were in the first line. Now that seems a bit complicated to me, so let me do a simple thing first, where yes, I'm going to read in a line of characters, and that's okay, because I'm pretty sure fgets is going to do most of the work for me. But then I'm just going to take a single character, and then I'm going to check whether it's in the line or not. So rather than doing this whole what I think is going to be a big double loop kind of thing, I'm just going to take this down into a single loop and just go, all right, line of characters, read in a single character, and see whether it's in the line. So, starting off with some ideas, where I'm thinking I'm going to use fgets. Nice thing is fgets comes from the standard input-output library. So, let's hop across to VLab, which is now functioning. And I'll go to my COMP1511 directory. Oh, I should have, it's always really funny if in this layout here with all my directories there, I just make a directory called final exam, so everyone's like, what's that? Can we see that? But no, I don't actually usually keep it in my account like that. So, oh yeah, there you go. There's lab questions from this week, I think, that I was testing in there, but I'm not going to show you those. Okay, we're in lecture 10 now. Oh yeah, there's also Minesweeper, but I'm pretty sure that's just the starter code that I downloaded in the live stream to show people how to download it. Okay, so I'm going to make lecture 10, go into lecture 10, so there's nothing in here just yet, but I'm going to make a file, and this thing was I guess I'll call it a word game. Wordgame.c. So I'm just opening my editor with a fresh file. Nothing in this yet. A word game demoing the halfway point of COMP1511. Oops. The annoying thing sometimes about having autocomplete is when it autocompletes the wrong word. Reads in a string of characters. Reads in another string. Checks how many letters from the second string are in the first string. Reports how many matched. Okay, that should be enough. What are we, 18th of the 3rd, 2020. I should also, it is nice to have an email address in there as well. You'll notice that in all the headers we give you for stuff like assignments and things, we have a section at the top asking you to put your ZID in there. I don't know if we ask for your email address as well, because given your ZID we have your email address, so it's, but at least name, date, and ZID. My ZID is kind of useless to you. It doesn't really mean anything to you because you're not assessing me specifically on my code or anything, so you don't really need my ZID, but we need yours for that kind of thing. Okay. I said I was going to include standard input output.h. Let me make sure everything is yeah, Andrew, the VLab's working today. So whatever it was yesterday, I thought it was maybe that everyone was suddenly working from home, but it didn't really make sense for that, because VLab doesn't actually take that much bandwidth, because usually it's just only a tiny bit of the screen changing at a time, so it doesn't need much bandwidth for that. But yeah, we're totally fine now. And I know this because I know that there's at least one other person in the house right now working from home as well, and I saw that they were in a teleconference with lots of people, so it's like, you know, it's busy. Okay, my int main. Here's my code that doesn't do anything yet, but at least I've stated what I'm going to do. I've included one library that I think I'm going to use. I might need other libraries, but I'm just going to wait to include them when I think I'm going to need them. And I've got code that runs. So if I go back to my slides, we were looking at reading in one line of code. So a couple of things we might want from this. If we're going to have an array, a string, which is holding an unknown amount of letters, I might need to have a maximum line length that I'm going to use. So I'm going to define that. Did I call it max line length? I did. I could use all kinds of possible values for my maximum line length. For the moment, I'm going to use something that's reasonably small, but I consider sort of reasonable for how much someone might type in as a single line of text. So I'm going to do 100. Actually, I'm going to be safer than that. I'm going to do 1024. This is going to use a fair bit of memory, but I'm sort of okay with that because I don't really have any limitation on how much memory I'm using right now. Why did I choose a number like 1024? This is a very, very computery thing to do. When we talk about computers being all in zeros and ones, that means that if I want a really nice lined up amount of memory, I can make what I'm doing one of the factors of 2. So if we go like 2, 4, 8, 16, 32, 64, you may even recognize some of these numbers, right? Into 32 bits, doubles to 64 bits and stuff. If you keep going up in that doubling scale, you're going to get numbers like 1024 and stuff, as opposed to numbers like 1000. There's no particular reason why I need 1024 versus 1000, but it's sort of this thing that we get into in computing where we do it anyway. And then what that means is this is going to line up really nicely in my memory somewhere, but really totally not important. But somewhere in my memory, there's a little OCD part of me that says this fits exactly inside a certain size box of memory. But, you know, not necessary. There's a question there, why do we always return 0 at the end of the main? You don't have to. If you want to, this closing bracket's going to return 0 for us. So if we made it to the end of the main, we're going to return 0. I do it sort of out of instinct sometimes, because often when I'm looking at functions, and I think of the main as a function, when I'm looking at the function, I look for the return word somewhere. But most functions, like if there was a void function, you wouldn't have a return symbol anyway. So I do it because sometimes I look for it. But it's not entirely necessary. In fact, if you want to, we can do this. Like, we can, I mean, as you said, Milkshake Gamer, you're saying in there, like, you've done it before without the return 0, and it's been fine. Yeah. So DCC's happy to add it for you. I don't know if there are other compilers that will complain without a return 0. I don't think that there are any modern compilers that require the return 0. So I think it's just something that I sort of do out of instinct. But to show an example that you don't necessarily need it, I'm happy to do it without it this time. Okay, so we have our maximum line length. If we have our maximum line length, then we want to be able to create an array of that size so that we have our memory set out so that when someone starts typing stuff in, we already have our memory ready to accept what someone's typed in. So it's going to be a character array. What should I call it? I wonder what I called it here. I called it the line. Yeah, that's fine, because it's a line of text. Maximum line length, like that. We don't have any information in this yet. I'm not initializing this with anything because there's no reason for this to have anything in it at the moment. So there's no default value we're working with. Alright, then we're going to do fgets. So fgets is a function you didn't write. It's a function that you don't have any information for right here. So there's no harm in going back and looking up what exactly fgets was if you forget what its inputs and outputs are supposed to be. So I'm going to go back to where I was talking about fgets the first time. It takes an array and a length and a stream. So the array is where it's going to write the information. This is very similar to how scanf said, give me the address of a variable and I will write into that address. An array is also, if I pass in an array, it's going to be the address of where I want this stuff to get written. The length is the maximum number of characters that it can read, and that's cool because we've got a maximum line length, and the stream is where it's going to read it from. So the array is line, the maximum length is maximum line length, And the stream that I'm taking it from is standard in. Standard in is the stuff that's typed in by our user. Okay, so this is probably going to get us our line. I say probably because we haven't compiled it yet, so we don't know whether we've done anything weird or anything. So what I'm going to do is test this using... Yep, too far back. Where did I go? I had... No, I think it was here. A simplified version of this where we're going to read a line in and we're going to write it out immediately. So for the moment, all this thing is going to do is just talk back to me. It's going to just tell me exactly what I just told it. But at least then we'll see whether the line's going into memory or not. So I'm going to fgets a line, and then I'm going to fputs that same line to standard out. Let me just make sure I've got my fputs correct. Fputs takes an array and then passes it to a stream. So that should be okay. So what I'm going to get here when I run this program is I'm going to type in a line. It's going to tell me exactly the same line that I typed in, I hope, and then it's going to finish. But at least we can test whether the input is working if we test this input and output like this. Clear this screen. So first thing I'm going to do is I'm going to compile my word game. I'm just going to call it word game. I can call it the same thing as the C file. And then I'm going to run word game. Oh yeah, I guess that's one thing. I didn't actually write anything to my user asking them to type anything in. So if I just gave this to someone, they'd be super confused. They'd be like, is this in an infinite loop, or is this just paused or something? But we know that it was going to take a line. So I will type in a line of text. Johnny used to work on the docks. I'm just going to wait till chat explodes. Anyway. And it returns the same line back to me. Johnny used to work on the docks. For anyone who doesn't know the song "Living on a Prayer," that's the first line of the song. So I'm just going all in on this one example today. So we got some questions there about stuff like standard in and standard out. Yeah. Standard in is the stuff that's coming to us from the terminal, basically. So the information that's being typed in from the user. Usually what happens is we type in a bunch of stuff, and then when we press enter, it all gets basically given to our program saying, you have stuff in standard in, do you want to do anything with it? And that's the point where fgets will start doing things. So it will sit there waiting, fgets will sit there waiting until you've typed in something and pressed enter. And then it will run this line of code, and it will continue into the program. Okay, go back to here. So now we know that we can take a line of code in, and being able to take that line of code, we can take a line of text in from our user, and we can store it, because we know we were storing it, because when we set it back using the fputs there, it had exactly the stuff that we typed in. So this line of code is not necessary for this program, but it helped me a lot to know that parts of my program are working. So yesterday, when I started talking about things like debugging and testing and things like that, this is the nice way to do it. So when I'm looking for errors later in my code, I'm pretty sure that the errors are not going to come from these lines, because I tested them to make sure they were doing what I wanted to do. So you can do this kind of thing where you know which parts of your program work. And so if you know which parts of your program work, you look for errors in the parts that are more volatile. The parts that you've written more recently, you go, all right, it worked before, and then I changed something. So the errors will probably stem from the things I've just changed. And we can only do that if we know that the code we've written before works. So this is another way that we can avoid errors by like piecing together our code. But every piece that we make, we test it on its own to make sure it works, and then we attach it to other things. We do that with functions as well. Okay, so then we're going to read in a single character. And so instead of reading in a single character via scanf, which is the way you know how to do it already, I wanted to use getchar, because I thought it would be interesting for us to use some of the new functions that we have, and we're probably going to build this up using some of these new functions as well. Union's been on strike. Yeah, he's down on his luck. It's tough. So tough. Anyway, okay, let's read in a single character. Okay, so we're going to use getChar to read in a single character. A lot of little things going on here with getChar. So, I'm going to get rid of this line because I don't need it anymore, because it was just testing that other one. Read in line of text. Actually, not even sure if I'm going to need to keep this reading in of a single character, but we'll see how we go. So, reading in a single character involves having a character to store the input that we get. So, input character. Note, very important, interesting thing. I just said I'm reading in a character, yet I made an integer variable. So if you remember yesterday, the getChar function that I'm going to use might give me a negative number. If it gives me a -1, then it means I couldn't read anything in. I got an end of file instead of a character, so I had to stop reading. That's what getChar will tell me. So if it gives me a -1, I need to have an integer with which to store that. So if instead of that I did something like char input character, I mean, you probably wouldn't even have to call a char an input char, but it can be handy. This thing only stores 0 to 254. Those are the values that a char can store with 8 bits. So if you only have 0 to 254, actually is it 0 to 255? 0 to 255. I'm like, I always know it's one less than the maximum, and I've memorized 255, and I took one away again. So 2 to the power of 8 has 256 possible values, and one of them gets used up for the 0, and there's 255 extra. So either way, this only stores 0 to 255 in terms of ASCII codes, which means it can't store the -1. Can't store -1. So if it can't store -1, if I put this into getChar, I won't know whether getChar was unable to read input or not. Okay, I'm going to get rid of that because I don't need that. I'm going to keep that as an integer. Just go back and look at my code. Yes. Wait, did we have a while loop there? Oh, this was to get more characters. If I want to, I can get more and more characters. But for the moment, I can just say input char is equal to getChar. I was going to say getChar doesn't need any input, but does it use standard in? No, it doesn't. So getChar just assumes standard input. So this thing is going to grab one character from standard input, and it's going to store it in input char there. So what this is going to do is just going to read one character. Let's make sure. Yeah, Abiram, thank you for answering a lot of questions there. I agree with your answers. Yes, the streams that we're using at the moment are all the stuff in the terminal, but then we're going to be doing other things. Hillary, the getChar is a function, and that function is going to give us a value to put into input char. So the value is going to be the value of the key that gets pressed. Humza, we're asking about why a char only stores 0 to 255. It's because it's an 8-bit value, so it actually has much less range of possible values than the 32-bit the 32-bit integers that we've been using. So an 8 bits worth of memory can only store 256 possibilities, and the way that characters are set up is to go from 0 to 255. So you could have 256 possible values that weren't necessarily 0 to 255, because you could encode it differently to be something else, but these happen to be like that. And that's the reason why we're using integers for these, because getChar, I'm just going to put this here, could return -1 if it reads EOF. So if it reads end of file, it's going to give us a different value in return, which is why we're going to want to read this as an integer. So Again, we could test this with another function that we can get from the standard input-output library, which is putchar. And putchar just writes out a single character to our output stream. So I can do input char there. So let's see if this is working by just seeing, can we read one character or not? So we're going to read one line of text and then one character. I'll compile this again. Compilation worked. And I'll run this. So the first thing was one line of text. So Union's been on strike. He's down on his luck. Okay, now let's just type in a single character. B for Bon Jovi. And we get a B back. Alright, so we know that our get char is working. It's taking in a single character because we just checked it to make sure it prints out the same character afterwards. So, this bit of code here, set up the memory for our string, use fgets to read a line in. It gets written into this array up to a maximum number of letters, which is 1024, reading it from standard input, which means the stuff I typed in here goes in. Then we read in a single character from standard input using getchar. So getchar got whatever was written in standard input, which happened to be a B there, and it got put into this integer. And this integer is now storing whatever ASCII value capital B is. I can't remember exactly. 60 something? I don't know, doesn't matter. Not important, actually. And you can see how I didn't need to know what value it was to be able to use it. So I stored it there in input char, and then I said, okay, write that out for me, input char, which is nice. We have it here. So we know that our reading lines and our reading single characters and our writing lines and writing single characters is working as well. So we know that we can use our functions to input and output now. I think that that's the point where... Yes, that's the point where I said I was going to go on break. Actually, let's look at some questions before that. We're looking at how many values we can get out of 8 bits. Yeah, what Griffin's saying there, we have 256, oh, not 256 bits, but 256 values out of the 8 bits, which I think is what you meant there. And includes 0, so it's a 255, yeah. So I think everyone's explaining that quite well, which is nice. Humza's asking what getchar is. Let me show you an idea of what getchar is. This is the same as scanf. Actually, it's not. It's not exactly the same. Scanf looking at a character and then putting it in input char. It's not exactly the same. I'm going to say very similar to. It's not the same because it doesn't do the same things with end of file, and it doesn't do the same things with certain characters. So this could be considered something that's going to read in a character and put it into that input character. This is doing the same thing, but it's actually a bit more specific. It will grab whatever is the first 8 bytes here, and it will definitely take them. Whereas input character might, scanf may not do this in exactly the same way. Yeah. So Humza, hopefully that gives you an idea about what this is doing. Getchar is a function that grabs a character from our standard input, and then its result of the function, so the thing it returns, is the ASCII value of the character that it read in. Yeah, and Abraham's got a good point there, is if I pressed the enter character, it would actually get the ASCII value of the enter character. And I don't... Actually, I've never tried that with scanf with a single character. I'm pretty sure scanf won't do that, because it won't necessarily identify that. Except I'd have to look up really carefully what symbols that this %C can match with. I'm going to leave this comment in here so that you can see that and remember that getchar does this. Getchar is very similar to this. Yeah, Abraham, I'm pretty sure it would fail the pattern match, but I don't know. This is something you can look up yourself if you want to. You can actually try that with different types of characters and see whether some of them work and some of them don't. Okay, so I want to go on break now. I'm actually a little bit over time as usual. I always like to talk for more than time I actually have available. So break time. I wanted to. This is a special break time. There's not usually in my Comp 1511 break times. I just want to talk a little bit about social distancing and isolation. So I apologize. I mean, I'm not apologizing because it's my fault. I didn't actually start the coronavirus. But still, I empathize with you that we have a lot of problems with having to stay home. Um, it can be a bit boring and stuff like that. But I encourage you to stay at home. Don't go out, don't see people, don't touch people. Figure out ways to hang out with your friends online. Online gaming is a lot of fun, just gonna say, there's a lot of cool things you can do. Um, so, as you can see, as the government's response to COVID 19 gets more and more drastic, um, we need to do everything we can to not spread this disease. So it doesn't really matter whether you're at risk or not. This is a matter of us trying not to allow this to reach a massive number of our population, and then it will overload stuff like our emergency services and stuff like that. So do what you can to try not to spread the virus, but at the same time, if you need any help now that we've gone remote, so things are different now, right? So I'm not there with you now. You can't just walk up to me um, and break time and ask me questions, right? Um, so you, if you have any problems, please let me know. Please let the course know. Let your tutor know. We'll help you as much as we can. And his last bit at the bottom here. So Isaac Newton, one of the most famous scientists in the history of humankind, possibly, arguably the most brilliant scientist in the history of humanity. Um, when he was in his early 20s, he was forced to return home and spend a year isolated because the Black Plague was happening at that time. And in that time, he discovered, if I remember correctly, he discovered the visible light spectrum of colors. And he discovered some really fundamental ideas about what gravity is. So yeah, I expect those kinds of results from you. I expect you to be coming back with uh, complete complete solutions to all of computing's hardest problems, uh, and we will and so I expect everyone to go well beyond Comp 1511 and be teaching this next year with the knowledge that you have gained in your time off. um, I haven't played Minecraft in a long time, but heaps of the tutors are super keen on Minecraft. And when I mentioned that actually it would be actually pretty easy to run a tutorial in Minecraft to the point where we could, what was it, the red brick computer? You can actually build a computer out of, no, redstone. It was redstone computer. That's how little I know Minecraft. You can actually build a computer out of Minecraft cubes, and then you could teach basic programming out of that if you wanted to. Anyway, yeah, it's redstone, isn't it? We're gonna go on break. So it's what, just past 12. It's 12:12 now. We'll come back at 12:15 and we'll continue that code, and we'll get more stuff going with characters and strings, and we'll talk about structs as well. Okay, be back soon. It appears that the normal conversations that happen in the lecture theatre are still happening. They're just happening over live chat now. I'm not that much of a Smash player myself, but I do appreciate the 9-9! Anyway, Terry does love his yogurt. Okay, let's get back into it, everyone. I figure we don't actually need big breaks. Actually, no, we still need breaks. You still need breaks in your listening time. Yeah, I don't know as well how the lectures translate necessarily to live streams. I mean, they seem to be going similarly. Oh, someone was asking before if weekly tests get marked on style. No, weekly tests are marked automatically the same way your labs are. If you are worried about style and you want to think about style, it's okay to take your weekly test and take it to a help session, for example, and show a tutor there and say, hey, can you look at this for me and see whether you think my code is readable or not? It's not going to change the mark you get from the submission of the weekly test, but it might be a good exercise, because you might be able to show your weekly test to a tutor and they'll be able to say, look, I think that if you just change this and this, it's going to be easier for you and other people to understand. So it's totally fine to take stuff like that and ask a tutor for a short code review of it, And I know some people have pinged their tutors about this with their assignments. You can't just dump a whole assignment on a tutor and expect them to do style for the whole thing at once, but if you want to, small sections of it, you can say, I'm having problems where I think that this particular part isn't readable. I think that I've gone too far in indentation. Can you give me a hand with how I might want to shift this? And they'll be able to give you a hand with that kind of thing. Yeah, and as Alvin's saying, the better your style is, the easier it is for you to solve problems. AA is asking if you can ask help from tutors for the weekly test questions. Yes, you can. But you can't post weekly test code on the forums because that spoils of other people who haven't done the test yet. So I think you can ask a private question on the forums. So you can ask a question that other people can't see about the weekly test and you'll be able to get help there. You can also go to one of the remote help sessions and ask for help there as well. And at the moment, especially because we're in assignment time, the remote help sessions are running every single day. So there should be a time that you should be able to make it and be able to talk to people. Okay, so let's get back into this. Alright, so we've been able to read in a line of text. We've been able to read in a character. So now we want to look through a string and see if the character is in the string. And so this is a perfect thing to push out into a function, right? Because it's going to have all this looping and stuff in it that you don't really need to specifically see in your main function or anything like that. But it's something that works quite nicely in terms of saying, I'm just going to do this test character thing, and then I'm going to be running this other code, but you don't need to know what it is. So that's the kind of thing that gets packaged off into a function quite nicely. So let's have a look at that. Where is it? It's here. Yeah. So let's create that function. So what was my output going to be? I definitely am going to need to have some output. So I'll have an integer. And I'll call this test character. And it tests a character. I don't know if test is the best word for that. I'm going to test the single character against a character array. I'm going to call that line because I think it's going to mostly be used with the line of characters, in which case the maximum size is going to be maximum line length. So copy that, put it down here, set it up with its curly brackets because I know I'm going to declare the function here and then define the function here. This thing's also called a function prototype up here because it doesn't have all of the information yet. Anytime I make a function, because I don't know where and when it's going to be used, I'm going to give people information on it, because without this information here, they may not have context there for how it was being used. Find a character in a line. I think this thing's probably going to return how many times that character appears in the line. I don't know if you just saw that. No, you wouldn't have been able to see that. My cat just jumped on my mouse pad. She's sitting like right there. She's right there. Hang on. My webcam. Hello. Hello. Anyway. Alright, back to me. Okay. So, this function is going to... And so, we have a potential issue here in that I'm taking character as input here, but we'll have to think about this, about whether we actually ever are going to get a single character or not, or this is going to be an integer, because here we're reading getchar as an integer. However, we should be able to actually give an integer as a character input, and it'll just treat it as a character. We'll see how we go with that though, but we have to remember this is something we want to look into later, make sure that it works. Okay, so we have our single character and we have our line, and so to find out whether the character is in the line, we know we're going to be looping through the line. So I'm going to set up a loop here. I = 0 while something I ++. Okay, I'm just going to add some white space down here. Actually, this doesn't... I did this on instinct because I like to keep things in the middle of the projector, but now that you're just seeing my screen, you can probably read this quite easily, no matter what. Everybody loves chicken. I always had this dream of having a dog that I would bring into lectures and would just sit with me in the lectures while I was teaching. And I live in a small apartment, so like it's really kind of, it's maybe feel a little bit cruel to have a dog unless I could walk it every day. And so I have cats instead, and so this is me living the dream finally, to have my pet hanging out here in the lecture with me. Okay, so we've got a while loop here, and this while loop is going to process all of the characters in line and check them all against single. So if it's going to do all the characters in line, then I want I to be less than the maximum line length. But as we've seen, I'm not filling up the whole string, so I'm not filling up 1024 characters, right? None of these lines that I typed in were filling up the 1024 characters. So I do want to check up until the last letter, but not past the last letter. If I go past the last letter, then I'll be checking random bits of memory that I haven't filled in with anything, and that could cause problems. So even though that memory is assigned to me, I don't know what characters are in that memory, so I might accidentally get like false positives and things. So I do want to stop at the end of the string. Recall that the string looks like this. There's the characters I use, and then there's the null terminator. The nice thing about doing this stuff with fgets and stuff is fgets is going to give me that null terminator. So it's going to read all the characters and then give me the null terminator, so that my string will always have that null terminator on the end. So I know that when I read in, I can stop when I find the null terminator. So that's the key element. I'm going to stop once I find this null terminator. And back to VLab. If I'm going to stop when I find the null terminator, that's me saying that line I is not equal to /0. So this is me saying read either until you get to the end of the array, or before you get to the end of the array. If you see this null terminator, that's where you're going to stop, and that's where you're going to stop looping through, because you've read all the letters that should be there. I'm going to put a comment in here that I know that at every point in my loop, so this is my inside the loop, comment, at every point in my loop, I've processed I characters. That's my way of remembering, so that when I'm thinking about my loop, I know that I've done that a certain number of times. So, if I've processed I characters, I know that I'm going to go through. I wonder if that's too long. No, I'm not hitting 80 there yet. That's okay. It's just my font's very large. So, this is definitely going to loop through every single character that's in use in the line. I have a friend whose dog is called Squid, by the way. So, yes. It's just me and my friends naming our animals different animal names. Okay, so this is going to go through every character that's in the line, and we're going to test each of those characters against this single. So, if we're going to test something, that's an if statement. So, if the single is the same as the current one in the line, then we're going to do something. What we're going to do depends on what we needed this loop to do. So at the moment we're saying find the character in the line. We're going to return how many times that character appears in the line, which means we are counting how many times that character appears. In order to count, I need a number that I can store the number of times I've seen the character. If I'm going to loop multiple times and I make a variable in here, that variable is going to be created and destroyed multiple times every time these curly brackets start and finish. So if I'm going to accumulate a value, I'm going to need it out here. So it's going to be a count, and it's going to start at 0, because if I haven't looked at the line yet, then I've seen the character in the line exactly 0 times. However, if I then see the character, so single is the same as the character that I'm currently looking at in the line, so I is going to go through the string and look at the characters one at a time. So if the single is the same, then count goes up by 1. If count goes up by 1, then that's going to go up for every time we see the character in the line. And then when we get to the end of this, we've processed I characters total, seen single, count times. So when we get to this while loop, these are the things we expect to have happened. Then, seeing as I've seen single count times, that should be the value that I can return. Okay, so this function here should be able to take a character and a line, find out how many times that character appears in that line, and then return that value. So now we can start thinking about using that. I'm going to get rid of this put char because we don't need the put char anymore. That was something we were using just for testing a second ago. And leave those comments in there in case people want them. Find how many times input char is in line. So now we're going to put this into effect, and we're going to say a new integer. I'm going to call it count as well because it's still the count of how many times something happened, and I'm going to assign to the value in count the result of this test char. So test char is going to take 2 inputs. First thing is a single character, and the second thing is the line. I'm going to try this, and we're going to see what happens. So I'm going to try giving it this integer, because this integer is an ASCII value of a character, and I'm going to see if it's okay with me giving an integer for a character. So I'm going to give it the input char, and then I'm going to give it the line. So with the input char and the line, this is going to, hopefully, we'll see what happens. We may get a warning, we may get an error, we'll see what happens. And this is something that we will maybe have to put our debugging skills into test, because we're potentially causing an error by putting a different type of variable in here. The result of this, if it does work, is it's going to tell me how many times that happened. And then I'm going to do a normal printf here because at this point I'm using combined things, like so I'm combining a string and an integer to output, so printf is a little bit more convenient for that. I saw this character this many times in the line. I could also print out the line, and the next line I could do an fputs for that if I wanted to. But for the moment, I'm just going to report the numbers. So I saw the character input char. How many times? Count times. Again, I am taking an integer and I'm treating it like a character. So if I said %d here, this would give me the value of the input character as a number. So that would give me the ASCII value or something. Whereas if I say give it to me as a character, it's going to convert that back into an 8-bit character, and it's going to give me whatever letter it was that I typed in. Okay, so let's just see whether this works or not. You have a chicken called Nightingale. Beautiful, that's great. Okay, so let's compile this. And the first thing that we're going to test is the compilation. Is it okay with this syntax of me giving an integer for a character function? It is okay with it. So what we're seeing here is that C is saying it's okay for you to give me a 32-bit integer for an 8-bit character. I'm going to say be careful with that, because if that 32-bit integer happened to be higher than 255, it would get cycled around. And if it was a negative number, it would also end up cycled around in some way to end up as a positive number between 0 and 255. I can't even remember exactly how that would happen. I'm sure there's a mathematical way that would definitely happen, but be careful with it at any time if you're storing something that's not an ASCII value and you pass it to a character function. So it's okay for the moment because this was intended as a character the whole time. Although we didn't even test if it's a -1. If this was a -1, then this is going to cause weird issues. Okay, let's try this anyway, and let's see if, barring us giving input that doesn't make sense, see whether this works. So the word game has Johnny's working the docks, Union's been on strike, he's down on his luck. It's tough. Oops. Spell that correctly. It's very important to spell this correctly. So tough. And then we had our put char, our get char that was going to see how many times a certain character appeared in this. So I'm going to go for a T because there's several of them, so we'll give it a chance to count things. I saw T 3 times in the line, so there's 1, 2, 3. Great. That's a good start. That means that we are able to read in a line, we're able to read in a single character, and with that single character, we're able to tell how many times it appeared in that line. Okay, so we can test for a single character, that's what we've got there, and so we've got our simple functionality here, and we can think about what we're going to do with testing. So syntax errors, we've tested that with our compiler. We don't currently have any syntax errors. Ulvester? Yes, this code will be available after the lecture is finished, so I will save this code. And looking at the time, I don't think I'm going to complete this entirely, so I may end up completing this in a video afterwards, after I jump across to structs to talk about those, because I'm going to save at least 15 minutes at the end to talk about structs. Okay, so if we are getting any strange behavior, we can guess what might be going wrong. We can confirm those guesses by getting more information out of our program. We've already been doing a bit of testing of getting more information out of our program by doing things like the fputs and the put char here, just to make sure these parts of the program were working correctly. At the moment, if I had any errors in the program, I would probably be going to look into this test char. because it's the most recent thing I've written, and I tested the previous things before, so I'm pretty sure they worked, and now I want to see if these other things work or not. But that's okay. Where was I going? Back to the slides. Yeah. So, we were looping for extra characters there. So that's something that I didn't actually do here, is they were also looping. I was also previously looping until input ends. So let's do that now, and let's loop through and grab multiple characters rather than a single character, and we'll see what some of those issues that I said were in my slides there. So at that point we were getting a single character, so if we want to, we can loop this to get multiple characters. So while the input character is not equal to end of file. So end of file is something that I'm going to get from my standard input output, so it's a hash define that already exists in there. So this while loop is saying it's going to keep scanning until end of input. I'll just keep scanning until end of input. I mean, it's awkward because it says EOF, but it's end of input. It's because this was built originally for file streams, and it would have a marker for the end of the file. But for us, with our standard input, it's the end of the input stream. Okay, so if we're going to read until we've read to the end of the input stream, the next thing that we're going to do at the end of this while loop is to read another one. Input char is equal to get char. So what we can kind of do with this is we can keep taking characters in one at a time, do something with each character, and then replace that character with another one and go back around and see if we can do something else. So we could, if we want to, do this, where we count how many times each character was in the line, and then we will be able to see how many times every character in a set of characters was in the line. So let's grab all of this and put it inside our while loop. I'm going to indent this so it's the correct level of indentation. I'm going to leave that white space there because this is the next thing in the loop, whereas this is the testing how many things happen. So this is probably going to print out a whole bunch of stuff, because for every character I type in, it's going to print out a line saying how many times it saw that. But this will be kind of useful. So let's save this and compile this, and then you'll see me checking not just one character, but checking multiple characters. So let's compile this, make sure that works, and then run that again. Okay, I really should have put a prompt in here saying please type in a line, because just having this blank thing here is a little bit odd. Johnny's working with Oculus, right? It's down like it's tough, so tough. What's the next line? Oh, Gina dreams of running away. Testing my karaoke here, how much I remember the words to the song. So Gina dreams of running away. Now, things have changed a little bit. I am not just inputting a single character. I am inputting a single character, but then that immediately goes into the test case of a loop, and that loop is going to read multiple characters. So I can type in multiple characters here. So let's type in Bon Jovi, being the name of the band that that wrote this song, and I'm going to press Control D, saying that my input is finished. So, oh, that's a bit awkward because that came up there because I didn't press Enter, but it saw B 0 times in the line, it saw O once, it saw N 4 times, 1, 2, 3, 4. It saw, oh, look at that, it's also checking for spaces. So it saw space 4 times in there, and some of the other letters it saw a certain number of times. So that's pretty good. Um. Oh, damn it. Gina works in the diner all day. Not Gina dreams. That's the second. I did the second verse, didn't I? Gina dreams of running away, is it? Or I just made it up. Maybe I'm just a brilliant lyricist, just as good as John Bon Jovi. Something weird here. I'm not sure why this is still going. So, one of these while loops is still going. Whether it's this one or this one, it's still running. I think it might be this one, but we'll have a look at that in a second. I will find out now when I Control C. Yeah, it was waiting for another character. Even though the last thing I typed in was a Control D. Oh well, we'll look into that. But at least we have this. And the interesting thing that we're seeing is we're not just checking all the letters. Unfortunately, we're also checking the spaces and things like that. Oh, there you go. I went to the second verse. Someone's gone and checked that. Sam went and checked that, maybe. Or you know it really well. That either says that you're checking too much stuff, or that's a very bad sign that you know all of the verses of the song. Okay, so what we're getting here is we can check through and see how many of the letters are or aren't in that line. And we don't necessarily need to print out this information. But what we can do now is we can actually put a count together that says how many of the letters that I typed in the second time were in the first one. So how many of these things were not zero? However, there's a couple of other things that we need to look at there. Okay, so we have some issues with extra characters. We also have some issues that we're talking about there is, are we going to account for capitalization? Do we want a capital B and a small b to also match up with Bon Jovi? It's Milkshake Gamer Lizard on a chair. Okay. So there's some things we might want to do to process our inputs so that they work in certain ways. I'm going to pause this code demo here because there's other stuff I want to talk to, which is actual content today, and then I will probably shift some of these ideas to a video. But some of the things I want to talk about that we could do. So the second line that we're testing the characters for has spaces in it. If I do this again, let's run this again. And Gina works at the diner all day. Okay, so I'll get this properly. Gina works at the diner all day. And then I type in Bon Jovi again and enter. Right. When I press enter, it goes in and does all those get chars. And so we get this really interesting thing happening here where the space is here. And check out this line here. I saw the gap 1 times in the line. Here, there's actually a new line. Someone's asking to see the cat. So this is weird because we really don't want this new line to be there, but we're seeing the new line 1 times in the line, which means the enter key at the end of this one and the enter key instead of in this one are actually being stored in our arrays. Well, the second one's not an array. The second one's just one character at a time. But the first one's an array, and we're actually storing the new line at the end. So we need to be careful. Oh, you can actually see it here. So there's a bunch of zeros there that we're not going to worry about, but there is what is stored in our line. So our line is actually storing new line at the end. And it's storing the null terminator. The null terminator we expected. We didn't necessarily expect we were going to get the new line there, except we should have expected that because we pressed the enter key at the end here. So this is something where the line that we think was typed in actually has more information. So lots of different things that we can do here. So Toby's asking, is this residual memory? It's not actually residual memory. We pressed enter. So if you think about that, I typed in Gina works the diner all day, and then I pressed the enter key, which is why the new line got grabbed in this fgets. So if you put an enter at the end, fgets is going to take the enter symbol, the new line symbol, and it's going to put that in the string. So the last letter of the string is not a visible letter, but it is a character. It has an ASCII code. It exists. So what we will need to do, several different ways we can get around this. One way is we can grab this new line and remove it. So we can look for the new line at the end, and we can say, take this out of the array. We can take it out of the array by replacing it with a null terminator, because if we put a null terminator here, it means that that is considered the end of the string, rather than the end of the string being considered after that character. I mean, if we wanted to, we could put a new line in here. Oh, sorry, not a new line, a null terminator anywhere in this string, and that would consider everything afterwards to not be part of the string, and only the bits in before it to be part of the string. So what we want to is we could find the new line and replace it with a null terminator. I actually have that in the slides. So new lines as characters. We could, if we want to, go to the last element of the... I've got that incorrect, but that should be line. We could go there and say, make this a null terminator. There are risks involved with doing that, because what if we got right up to max line length and the enter wasn't in it? Then we're just going to be removing one of the characters. Oh, really, really good question from Milkshake Gamer there. Is new line one character or two characters? It is one character. So the slash is nearly not considered a character. The slash changes your mode of what you're doing things. So it says this is going into a mode of non-visible characters to do certain special commands, and then if we do an N after it, that's a new line. The slash is doing non-visible things. If we do a 0 after it, that's a null terminator. So the slash is actually sometimes called an escape character, and it escapes from the normal way of doing things and allows you to do other things. So we could remove the new line at the end of the string, or while we're reading input, we could ignore the new line. Oh, we could do both of those things, because one of them is for a full line. Let me just... that is going to get confusing. Oops. Oh, I'm trying to get to that bit of text. Oh, well. Here we go. No. Alright, I'm going to leave that for now, but I want to change that line of text to line. I'll sort that out later. Yeah. So there's a few things we could do to clean up what we're doing there to make sure that things like new lines and spaces aren't there. There were other questions as well about whether we want to ignore case. We can if we want to ignore case. We could ignore case by making everything in both sets of input lowercase or everything in both sets of input uppercase, and we could go through and ignore stuff like spaces as well. So I'll see about making a video later to go into more detail about those things. But I like that everyone's sort of starting to think about it this way as well, because these are the things that you might want to do if you were... I can leave this with you as a challenge, actually. You can keep working on this and see how you're going with that. Alright, so first thing we did was check single letters. We read them into the word and stuff like that. We could use functions. We could also be doing things like... this main's actually pretty heavy here. This reading input could have been in a function as well, so we could have done this differently. There's a lot more that we could do with this, but I want to skip on to structs, because I wanted to at least talk about these, because technically the way that we could think about this is that this is kind of the last lecture with content before week 7, so I wanted to at least cover this before we continue on. I am going to still be talking to you in week 6, I'm not just going to abandon you entirely, but anything that I'm going to do in week 6 will not be accessible content, it'll just be for interest. So I might do a recap of the entire course, another program that uses a whole bunch of stuff, or I'll continue that one. Maybe I'll continue that one in week 6 and do some other stuff. But I also want to talk to you about a few things that are not accessible, but they're useful to know about. Okay. Structs. C structs are the way that we can create our own variable types. So we're going to actually be able to build our own variable types, and they're for use for ourselves in our own code. And they're variables that are made up of other variables. So we've already seen variables made up of other variables. That's what an array is. An array is a variable that contains multiple variables. But the key difference this time is a struct does not contain all of the same variable. You can mix and match. You can have lots of different variable types all in it. So this is why I've got a picture of a bento box here. A bento box has all these different sizes and shapes of things in it. So it's got this big chunk here, which is rice, and this smaller chunk here, which is salad, and that one, I think that's looks like a fish head maybe, or something, and there's another salad over there. Oh, that was sashimi, and there's salad there, which means you have a piece of memory, and then in that piece of memory you've got all these different shapes of memory. So you've got an integer shape of memory for some struct, and then you've got an array shape of memory in there for a whole bunch of other integers and things like that. So we can build a struct by piecing together a bunch of different variables that may not even be the same size. So the array was really nice and uniform because every chunk of the array was exactly the same size. Struct, not so much. You can have different size bits of memory. Okay, it's not a fish head, it's something else. I'm not sure what it is. I just took that photo from, it's probably a Google image search or something like that. Okay, so before we can use a struct, we need to declare what it is. So we need to be able to say, I'm making a new variable, the variable has a name, and then it has some information inside it. So I'm just using a particular demo here of a performer, and this is a test. I've like this whole lecture was about music, I think. I just realized, because previously we had some old American pop rock, and now we're going to have some slightly more modern stuff in this next example. So to declare the variable, we have to give it a type name. So in the same way that integer is a type name, double is a type name, char is a type name, actually int, not integer, we are making up our own. So this is struct performer. I'm making a struct for some kind of music performer here, and they're going to have a name and a description and a rank. I gave them a rank because in a group you could consider some people to be the leader of the group and other things, but I'm just rolling with that for the moment. I just wanted to show you that you can have different types in here. So I've got a string and another string and an integer, which means all of these are contained in the variable itself. So to create this variable, we could declare the variable in the same way that we declared another variable, but now instead of int for the variable, struct performer is the entire type. So we now have a two-word type. In the same way we can have int as a type, now struct performer is a type. So this struct performer is called rm. So rm is the variable name, and struct performer is the type. In the same way I could have an int rm, and int would be the type, and then rm would be the variable name. So rm is the variable name here. And then I'm using some of the functions that I was talking about before in the strings, like string copy. So the actual data types that are inside the struct is a name and a description. We use a dot here to say, I'm using the variable, and then I'm accessing one of the fields inside the variable. So each of these could be considered fields inside the variable that are their own functions. Have I got anyone yet with this example? I only just recently got into BTS in the last couple of months, so I'm several years behind everyone, but I'm slowly learning who everyone is in the band itself. So I don't know if there's K-pop fans out there, but if there are, hopefully this resonates with you. Okay, so to access the individual fields inside the variable, we use this dot to access inside. So if I want to change the name that's inside there to this string, I would then access the field like this. I can't assign a string immediately, so I'm using this string copy function, but I can assign a rank here like this. Oh, some people don't like K-pop. Oh, that's a bit sad. I think they're a lot of fun. I like watching them because it's like a soap opera. It's like you get to see them all and all the different things they do, and it's really funny. Okay, so RM is considered the leader. of BTS, so I gave the rank 1. So what this is going to do with the struct is we've got these fields in the struct that can contain information, and we're putting the information into those fields by accessing the field. So if I do rm.name, that's the same thing as just looking at a string. If I do rm.rank, that's the same thing as looking at an integer, and then I can do any changes I want to that integer, and if I want to, I can print them out as well. So in the same way that we used an array where we had like a whole bunch of elements of the array, and we used an index to get to a certain element, and then once we got to a certain element, we could treat it just like a normal variable. The structs are the same. Once we can access one of the fields in the struct, we can just treat it like a variable. So here we're using string copy to copy this in, but here, this is the easiest way of thinking about it. rm.rank just gets to one of the fields inside it, and I can set it to that number. The next thing that we're going to be using a lot is we're going to be putting pointers and structs together a lot. So we're going to be aiming pointers at structs, because structs are big chunks of memory. So we're going to aim a pointer at the struct, and then we're going to follow that pointer into the struct to get things inside it. So, for example, I have a pointer to this rm variable that I had before. So I've gotten the address of the rm variable, and I've made a new pointer called wrapper. And then the pointer called wrapper aims at this struct. So in the same way that we could put pointers aiming at integers, we can put a pointer aiming at the struct performer. So struct performer here, whenever you use the keyword struct, it's usually going to have a word after it, and that will be the entire type of this pointer. So this pointer is pointing at this variable. So this would suggest that the way that we would access something inside is we put the star in front of it. The star in front of it would follow this pointer to the variable rm, and then the dot would allow us to access that variable. So I could change the rank to 100. But we do have another symbol here that allows us to do this in a slightly different way, that allows us to sort of see a little bit clearer what we're doing, where we have the pointer and then we have an arrow to a field, and the arrow here says I've got a pointer, and the pointer is aimed at an object. I'm going to follow the pointer to the object, and then I'm going to look at one of the fields inside the object. So this kind of syntax for this is how we're going to be using this most of the time. Most of the time we're going to say, if we have a pointer to a struct, we are going to use this terminology to follow the pointer to the struct itself, and then look at one of the fields inside the struct. So structs are variables. If I say struct performer something, then I'm saying that I'm declaring a variable of that type, which means that anything that we can do with variables, we can do with structs. We can put structs into an array. So if, for example, I wanted all of BTS, I could have multiple struct performers in all the different names, like RM, J-Hope, Jin, and Jimin, and all the rest of them, and then have them in an array, access them via their index, and then put their names in and stuff like that. So we can have arrays of structs. We can also put structs inside structs. So I could have another struct, which is BTS, and that struct could have 7 performer variables inside it. And so we can have structs inside structs. And so the idea is we create our own variable type, which is a struct, and then we just keep using that as a variable. The only thing we need to do is to make sure that we've declared the struct at the top of our code before we start using it. So I think I've got a couple of questions there. Well, I might actually take the questions after time, because I'm right on the edge of time there. So we are going to look at structs later. I will probably do a bit of a demo with finishing off the characters and string stuff, and another demo potentially with structs. I'll release those probably as videos, or do some live streams next week. I haven't decided whether next week as a flexibility week is going to have the same timing, because we won't necessarily do the Tuesday morning, Wednesday mid-morning kind of thing. We may just release videos to you, because it's supposed to be a kind of a week off. It's not supposed to be something where you have to turn up at particular times. We'll see how we go. But if I do anything during the times and live streams, those will be specific, specifically things that are not accessible. So there'll be things that you can just do optionally out of interest. Okay, so stuff that we looked at today. We expanded characters into strings. We looked at a lot of the code for the characters and strings, and then we also started looking at structs. So I'm going to wrap up the lecture there. That's the official lecture over. So especially anyone who has to go to tutorial now, go to the tutorial. But I will stick around for a little bit and answer any questions there. I will not be talking about whether people actually like K-pop or not. But if anyone has any code questions, I'll stick around and answer your code questions. So let's have a look at what kind of questions people are asking here and whether people need any help with that. So if you have a tutorial to go to now, feel free to go to tutorial. So this is just me answering individual questions for the next couple of minutes. Think of this now as me sticking around at the end to answer questions if anyone has any, but if you're here for the lecture and you've got other classes to go to, please go ahead and go to the other classes. Okay, so we've got a whole lot of conversation about J-Jazz, Japanese jazz, I assume, which is pretty cool. I've heard a lot of that myself as well. Why is rank not considered as an array? Is it automatically assigned to the name? Okay, let's go back. When we create the struct itself, we create the variables that are inside the struct. So the integer rank that's inside the struct is a single integer. That's it. So every field in the struct can be a variable, and variables can be of different kinds. So you can have variables that are arrays, but you can also have variables that are not arrays. So the integer there is just a single integer. And the other thing to think about when we're accessing fields of a struct is we access the fields by name, as opposed to an array where we access fields by index. And the index was literally jumping along in memory a certain distance. Whereas the structs, you can't tell exactly how far along in memory you're going to jump, so they have names for where you can reach the piece of memory inside the struct to find things. The question is, would the variable name be the thing that we change to make more of it? Like, is one RM and the other's V or Jimin and that kind of thing? If you're going to make multiple structs, then you need them all to have different variable names. So in the same way that if we were making multiple integers, for example, every integer needs its own name. So yes, each one would have to have its own name. These structs happen to have a name field as well, where you can put a whole string in there. And that might be used, for example, if we were going to output the name of the variable RM, this is the kind of thing the human would see. So we have one name for it. It's not even really a name, but the variable name that we might use within the code. But then we might have something like, considering this is a record of an actual human being, they may have a title or something that they use. For example, Rapmaster uses, he doesn't use that as much anymore, but still, that's the thing that we could display on screen to identify it. Arrow syntax. Can the arrow syntax be used for all pointers or just structs? Let's go to the arrow syntax. So, if I have a pointer and I want to read the value of the pointer, I use the star on the pointer. The arrow syntax is more particular than that. The arrow syntax doesn't just follow a pointer to a location. It follows a pointer to a location, and then it looks inside the struct at that location for this field. So, the arrow notation will only work if there's a struct with fields at the other end to give it this name. So we can't just do pointer arrow and then get the value that was inside a pointer. So if I pointer to a normal variable, so a pointer to a basic variable like an integer, I can't use this arrow. So if I'm using a pointer to a basic integer, if I want the value, then I use the star. If I'm looking inside a struct, so I'm following a pointer to a struct and then looking at one of the fields inside the struct, that's where I'd use this arrow. Then we're talking about struct deception. Oh, and Abiram was answering that one as well. The dereference doesn't really make sense for other pointers, which is true. Um, oh, and there was a question there about string copy. Oh, how does string copy work? Sorry, I skipped that. Let's go back to the strings, because I definitely had... Oh, too far. String copy. Copy the contents of one string into another. So string copy is nearly like a while loop that's going to go through and go, okay, first character in the source and destination string, so it's going to copy from one to the other. So it says, what's the first one there? Copy that into the first element of the next string. What's the first one here? Copy that into the element of the next one. This is because you can't just straight out say, make this array equal to this other array. Because arrays don't work like that. They're not single variables, so you can't just go copy the value of this array and put it in this one. If you tried to do that with an array, what you would be doing is just moving the address of the array around. But what you really wanted to do in this case was grab all of the contents of the strings and move one from the other. So, oh yeah, but Toby's saying there that you understand that, so that's fine. Any final questions? If anyone would like to ask some final questions, I'll stick around for a little bit in case you have any more questions. Christian is saying, let's play Fortnite. Look, I'll be honest and say I'm old and I don't have Fortnite installed on my computer. I do have, what I've been playing recently is Borderlands 3. But most of what I play is actually tabletop games and stuff, so it's not not that often that I actually play computer games so much these days. Strangely enough, this last weekend and last few days, I've been frantically trying to make sure that if we took this course online, it was actually going to survive as a course. And I hope that it's surviving. But any problems, right? Any problems you have, please let us know, because we still have like a certain amount of flexibility in how we deliver the online content. So if there's any issues with the online content, or if there's anything your tutor did really well in the transition to online, let me know that as well, because I think what we're going to try to do is pick out the best way to deliver the online content, talk between all the tutors, let everyone know what was working in different tutorials, and then when we come back for tutorials and labs in week 7, hopefully everything is going to work well. Oh my god, Baldur's Gate. Wait, Baldur's Gate 3? Is that new? Or is that super old? Because I remember playing Baldur's Gate games on my, like, Xbox. Not Xbox One, but, like, Xbox. The first Xbox. I was going to say Xbox One. But no, the super, super old Xbox. That came out when I was at uni. And Hillary, I apologize. I don't play enough Smash Bros. To have a name. Also, one of the tutorials has already started, so a lot of you shouldn't be here in the live chat talking to me about computer games. You should be in your tutorials. Okay, I'm going to wrap it up there, because I think we will just devolve into talking about computer games if I continue doing this. So, thanks everyone. Go to your tutorials, and I hope everything's working out okay. But obviously, any issues at all, you're free to message the forums, myself, talk to your tutors, anything that you need. We'll try to help you while we're all isolated and distant. But obviously, also want to go back to, where is it? Yeah, make sure you discover some fundamental elements of physics. Alex, not all tutorials at the same time now. We understand that a lot of people still have a lot of timetabled stuff, so not everything has shifted online at UNSW yet, depending on the difficulty of taking a course online. Ours was obviously very easy because you were working off web pages already for all the labs. You were working off VLab already, so it was much easier for us to go online than other subjects. So while other subjects are still taking their time, they still have a lot of scheduled things, so we're sticking to the schedule. Yeah. If You going home and not being able to be at uni and stuff means your schedule changes and you can't make your normal tutorial. The same thing that would have happened during term with face-to-face tutorials. If you need to go to a different tutorial, you can just go to that other tutorial. Just if you do need to go to a different tutorial, let the tutor know that you're like, hey, can I sit in on this? Because we still want to maintain our teacher to student ratio on things. Okay, I should head off. Thank you, everyone. Good luck with everything, and good luck with assignment 1, because we won't necessarily be talking that much between now and when it finishes. Help sessions are obviously available, and there will be some content next week, but not that much. But anyway, I will send out information at the end of the week, my weekly notice about what we're doing week 6. So Sam's asking how we access the tutorials. There's a Moodle link to a Blackboard Collaborate. So there's a system called Blackboard Collaborate, which is the system we're using for tutorials. There's a Moodle link there. You'll be able to find links there to all of the different tutorial sessions, so you can find yours, your normal time slot there, and then by clicking that link you can go into this like live video chat system that allows you to do that. Whether or not you use a camera or microphone is up to you. I encourage at least using a microphone so you can ask questions and things, but you don't necessarily have to use a camera, because it's a potential breach of privacy if you can't set up your camera in a space that doesn't show private things about your house and stuff like that, so it's your choice about that. Okay, I'm going to wrap it up there. Thanks everyone, and I will see you soon.